This is the first steering mechanism for my custom RC car. It's fully 3D printed, driven by a real servo, and in this video I'll show how I designed it in FreeCAD, printed it, assembled it, and got it working. To build a fully custom RC car, the first thing I need is a steering system. It needs to be simple, easy to print, and strong enough to support the weight of the vehicle. The car will be powered by a USB power bank. The idea is to mount a servo inside the chassis with its shaft pointing down. Under the servo there is a bearing, and through that bearing runs the steering shaft. The servo rotates the shaft, which turns the front wheel assembly. The shaft has a slightly larger section here. That way the weight of the car rests on the shaft and the bearing, not on the servo itself. There is another bearing which is used to mount the wheels. I started with a bearing, since it defines the main dimensions of the steering mechanism. I measured the real part with a caliper and recreated it in FreeCAD so the printed part would fit correctly. Next, I designed the shaft that will rotate to steer the wheel. At the bottom, I created the holder for the wheel axle, which will eventually connect to the wheel. The shaft then continues upward into the steering bearing. The lower part of the shaft is slightly larger in diameter. This allows the weight of the car to rest on the shaft and the bearing instead of putting the load on the servo. At the top of the shaft I've added a square extension. This makes it easier to attach an adapter that connects the shaft to the servo arm. The adapter slides into the square shaft and has a cutout that fits the lever from the servo. To make sure everything fits correctly, I also measured the servo and created a simple model. Then I designed the frame that holds the steering bearing horizontally and mounts the servo directly above it. With all parts ready, I assembled everything in FreeCAD to verify that the mechanism moves correctly. During assembly, I noticed that there wasn't enough space for the mechanism to rotate freely. Increasing the space between the parts fixed the issue, and the assembly started working as expected. Once the design looked correct, I exported the parts and sent them to the printer. After printing the parts, I started assembling the mechanism. The bearing is inserted into the frame and the steering shaft slides through it. The adapter then connects the shaft to the servo arm. Before installing everything into the chassis, I powered the electronics to verify that the mechanism works. Once the basic test worked, I installed the electronics into the printed structure and connected everything together. With everything assembled, the steering mechanism works smoothly and behaves exactly as expected. Now the car can steer. The next step is designing the drivetrain so the vehicle can actually move.